We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hey guys, today we are going to discuss the topic of isolated column footing of the subject Elementary Structural Design 6M Civil Engineering. Myself, Assistant Professor GAURANG Prajapati from Civil Department, MGT College, NAVSARI. Let's start it with the introduction. Say why the footing is provided, or we can say what are the functions of footing. Foundation is the lowest part of the structure which is in direct contact with the soil and transfers the load to the soil beneath. Means footing transfers the load of the structure to the soil. Footing transfers the vertical load, horizontal load, moments and the other forces to the soil. Footing has to be designed to safely transmit the load of the structure onto the sufficient area of the soil. And in the last, if a soil is overstressed, it may lead to the shear failure, resulting in sliding of the soil along a plane of rupture and thus result in the collapse of the structure. Now, talking about axially loaded footing, that is, for RCC column, normally the isolated footing are provided because the design and the construction of such footing is very simple and economical. The isolated footing for the column may be pad footing or we can say slope footing. Starting with the first one, pad footing. Now the pad foundations are generally shallow foundation but can be deep depending on the ground condition. Now over here we can see that I have shown over here the elevation and plan of the pad footing. Say this one is our column that is shown over here, while this portion is, we can say, this footing. Now they are the form of the spread foundation formed by rectangular, square or sometimes even circular concrete pads that supports the localized single point load such as structural columns, or we can say the group of columns or the frame structure. Means in simple word, it carries a point load. That point load can be described as a column. The load of column will be transferred from superstructure to the, we can say, substructure, to the footing and to the soil. Now we can see over here I have shown the figure of the pad footing over here. Now second, that is slope footing. Slope footing are trapezoidal footing. They are done with the great care to see that the top slope of 45 degree is maintained from all the sides. So over here we can see that this slope, that is, we can say 45 degree, that has to be maintained in case of the slope footing. Now when compared with the trapezoidal footing with the flat footing, we can say pad footing, the usage of concrete is quite less, thus it reduces the cost of footing in concrete as well as in the foundation. Over here we can see in the figure I have shown the elevation, that is over here. This one is our elevation, this one is our plan. Now we can see that column, that is this one, that is shown over here. Now these are the slopes which we can see in the plan, that is at 45 degree with respect to the bottom surface, or we can say from the flat surface. Okay. Now next, that is, these are some of the figures of the slope footing. We can see over here that from the ground surface we can say these 45 degree slopes are maintained with the ground, and this one is our column. Now bedding capacity. Bedding capacity of the soil. The size of the footing depends upon the bedding capacity of soil. The load on the unit area below the footing shall be less than bedding capacity of the soil to prevent the settlement of footing. Then gross bedding capacity, total pressure acting at the base of the footing including self-weight of footing, weight of column, overburden pressure of soil above footing, etc. is called the gross bearing capacity. In simple word, if I want to make the formula of the gross bearing capacity, that is equals to self-weight of footing plus weight of column. So footing's weight is there, column's weight is there, and overburden pressure of the soil above the footing. Then safe bearing capacity. the net pressure at the base of the footing after deducting the weight of excavated soil, or we can say the overburden soil pressure, is called the safe bearing capacity. If you want to make the formula of this one, safe bearing capacity equals to gross bearing capacity, that is all the bearing capacity, minus overburden pressure. Okay, now the formula of it, Qn equals to Q minus gamma into D, where gamma, that is density of soil, and D, that is depth of footing. Now minimum reinforcement requirement for footing, that minimum reinforcement criteria for the structure, AST minimum equals to PT minimum B capital D by 100, where B equals to width of footing for pad footing, and if you are designing slope footing, then B will be the width of column. D, that is the overall depth of footing, while PT minimum, that is minimum percentage of steel, that is 0.12 for the HYSD bar, that is Fe 415 and 500, and 0.15 percentage for MS bar, that is for Fe 250. It is given in the code IS 456, close number 26.2.1, 5.2.1, and page number 48. And for footing, minimum cover of 50 mm are required. Now spacing of the reinforcement bar, while deciding the numbers of bar, we have to maintain the spacing between the bars, that is given in the code. Now this spacing varies as per the grades of the steel. For example, for Fe 250, this clear distance between the bars should not exceed 300 mm. For Fe 415 it is 180 mm, and for Fe 500 it is 150 mm. It is given in the code IS 456, table number 15, page number 46. Now the reinforcement of the pad footing, I have shown it over here. Now we can see this over here, plan and elevation both are given over here. Now this one is our column, that is in the plan we can see over here, while these are the reinforcement of column, or we can say these are the stirrups. Okay, or in case of the column we can say it is a lateral tie. Okay, while this one are the bars, or we can say the longitudinal reinforcement of column. Okay, over here in 3D view we can easily identify that these are the reinforcement of column. See this lateral ties and the vertical reinforcement, that is longitudinal reinforcement, while this is the reinforcement of footing. Now the bars are provided along the both directions, we can see like this and like that. Okay, so what does footing do? That is, it transfers the load from the column, that is from over here, to the foundation, that is at the soil below it one. Okay, so hope you guys got the concept of all the, we can say, basic concepts of the footing. Okay, thank you.